In this lesson, we're going to find the difference quotient. Earlier, we learned to calculate the average rate of change by using the slope formula. The average rate of change between 2 points is the slope of the secant line and is given by the equation following. This expression is called the difference quotient and is very important for the foundation of calculus. In this section, however, we're only going to just evaluate the difference quotient of two functions, which means we're just going to scratch the surface of this particular topic. You'll learn more about the difference quotient in your calculus course. In this example, we're given f of x equals 3x minus 5 and asked to find the difference quotient. So you are given here the difference quotient formula, which is f of x plus h minus the function over h. So what does that involve? Well, first you're going to into the function evaluate it for x plus h. Then you're going to subtract the function itself all over h. So let's first evaluate it for x plus h. We're going to remove the x of the given function and replace it with x plus h. Now we're going to simplify that. To simplify that, we're going to use the distributive property, and that's going to be 3 times x and then 3 times h. And that's about it as far as simplifying. You can't do more. So next, you're going to subtract the function itself from that. And it's going to be all over h. So when you do so, this is how it looks in terms of the setup. So again, you have evaluated f of x plus h, and then you're going to subtract the function itself. Now keep in mind, because this second group, the function itself, has a negative in front of it, you must change everyone in that group to their opposite. So it's going to become negative 3x plus 5. Now we're going to go ahead and combine like terms. We can see here that our first degree terms of x are opposites of each other. We have 3x and minus 3x. They will cancel out, and so are our 5s. We have a both positive and negative 5. And that will always happen with difference quotient. If you don't have terms that cancel out, then you probably did something wrong somewhere in your math there. So once we take away those terms, what we're left with here is 3h over h. We can then cancel out the common factor of the h, and what we're left with is simply 3. Let's do another example. In this example, we're given the function f of x equals x squared minus 7 and asked to find the difference quotient. So let's go ahead and proceed first by evaluating the function for x plus h, meaning remove the x and replace it with x plus h. When we do so, it's going to look like so. So here, because we have a binomial squared, we need to first solve that or simplify that. And recall, we can use that square of binomial formula method, which means square the first term. So the first term will be x squared. To get the middle term, multiply the number 2 with these numbers. So the middle term is going to be 2xh. To get your last term, square this number, and that's going to be h squared for your last term. And then notice we have the negative 7 there in the back. So we have done the first part, which is to evaluate the function for x plus h. Now we need to subtract the function itself, and here is the function. So once we set that up, it's going to look like so, and you have h under the bottom. Keep in mind that with subtraction, because that second group has a negative in front of it, you must change them to their opposite. It's going to become negative x squared plus 7. And now we're going to cancel out any opposite terms. So what terms do you see that are opposite? That's correct. If you said the x squareds, they're opposites, and what other number? You got it, the 7s. So let's go ahead and cancel those out. And now I'm going to write what we have left. Okay, on top, it looks like we have a common factor that we can take the GCF out, the greatest common factor, because they both share these two terms on tops. They share an h in common, so let's factor the h out, and we'll write what's left in parentheses. And now that we have that factored out, we can cancel a common factor of an h up top with a common h down below. Once we do that, we are left with 2x plus h, and that is our answer. Okay, so it's your turn. Here I want you to evaluate the given function here of 4x squared plus 5x. Find the difference quotient there. You may want to pause the video and work the problem, and then after some time you can start the video back up and I'll reveal the answer. Okay, so hopefully you had some time to work that out. If you did it correct, the correct choice should be A. If you wonder how that became so, let's go over it real quickly. So we want to evaluate the function that we were given. First, we want to find f plus x plus h. So into this function, I'm going to move over here to the left where I have plenty of room. We're going to remove the x and replace it with x plus h. That's squared. Plus 5 times, and again we're going to plug in x plus h. And actually let me do that in a different color so you can see actually that we did plug in the x plus h into the formula, into the function itself. Alright, so going back to my red here, we know that the binomial squared of x plus h, to get that I'm going to square the first term, multiply the number 2 along with those two numbers in the parentheses to get your middle term. To get your last term, square the last term of h squared. Next we have plus 5, distributing that 5 times x is 5x, 5 times h is 5h. Now we have to distribute the 4 to every term in this parentheses. 4 times x squared is 4x squared. 4 times 2x8 is 8xh. 4 times h squared is 4h squared plus 5x plus 5h. Yes, that's a lot. All right, and next we are going to do the second part, which is to subtract the function itself. So because I'm subtracting the function itself, everyone in that group has to be changed to their opposite. So what you're going to wind up having, and I'm going to add that to what I already have. Adding that to what I already have, I'm going to have in the back negative 4x squared minus 5x when we change the signs to their opposite. And all of that over h. Okay? And just so you're able to focus your attention on what we have here, now it's time for us to do our cancellation. What terms do you see that, well, actually you did the problem already. So what were the like terms that were opposites of each other? Did you say 5x? Yes, you're absolutely right. Okay, what else did you get? Yep, 4x squared. Yep, you got that. Anything else? Okay, no, that's it. So, what we have there left over, and I am running out of space here. So let me just erase what I have there up top so that I can utilize that space. So give me a moment to do some erasing. Because I need space. Okay, that should do it. That should be enough space there. All right, let me grab my pen again. All right, so what we are left with is 8xh plus 4h squared plus 5h and all over h. Now you notice I kept saying h there up top. So there's a common factor of h that we can take out of each one of those terms in the top. So when we take the GCF of h out, what we're left with here, and let me erase that arrow that's in the way there. Okay, so if we take the h out of that first term of 8xh, what we're left with is simply 8x. And if we take the h out of the 4h squared, we're going to be left with plus 4h. If we take the h out of the 5h, we're just left with 5. And all of that over h. So all I did here was I took this expression here and we rewrote it over here. Okay, went from here, this is what it looks like, and then here we took out the GCF of h. And now lastly, we're going to do our cancellation of canceling the common factor of the h out. And what you're left with then is 8x plus 4h plus 5, which is choice A. So yes, some of these with the difference quotients may be a lot of work in terms of the terms, but if you just be patient with the process, you'll see that it's not bad at all. Okay, that's it. Okay, that's it for this lesson. Thank you for watching math videos on PowerPoint with Dr. Speights. I hope you were able to learn something in this lesson. Please feel free to like, share, and subscribe. Bye-bye.